So thank you for joining me this afternoon. It's a pleasure to be back here to Insomniac, and hopefully we're going to have a good time with malware analysis with R2AI. The goal of today is kind of a little bit selfish, to be honest, because it's to ease my own work. So as you might know, some of you at least, I'm a malware analyst with Fortinet. And so I get kind of incoming malware to analyze like every day. And if it's just to detect the malware, that is pretty quick. It's under 2 hours. That's okay. But if I need a full analysis of the malware, it's going to take between half a day to up to 10 days, depending on malware complexity, how much details I want, and my own skills, of course. Okay. Typically half a day is going to be rather if it's just like a variant of another malware that I have already analyzed and I just want to dig in like a small different part in it and want to peek into that. I'd say that most of the time it will typically rather take me around 3-4 days to do a full analysis of a malware. So the obvious question there is, well, we've got artificial intelligence. Can it help me out to speed up this analysis and do that faster than those 3-4 days or up to 10 days, depending on how lucky I am? And doing that, I do not want to lessen the quality of the analysis, right? I don't want to get something in 1 hour which is totally crappy. I want something which is decent quality, just faster if this is possible. When I started the research, like a couple of months ago, to be honest, I really did not know what would be the outcome of the research. I did not know if it would be positive or negative. Because I had around me people which were like on both sides telling me either that AI was great or that it was like just the devil. Okay. So in between, I just wanted to try. I decided to use 3 different malware that I selected from 2024 and some more recent ones there from a couple of weeks or months ago, that I had never analyzed myself before, so that my analysis would not be tainted by some kind of prior knowledge. And I wanted to compare my analysis using AI with the analysis of a human-based only analysis. So other researchers have analyzed those, and I'm going to compare my analysis with theirs. Okay, and the links for their analysis is there. You will be able to follow those links afterwards with the slides. Before we start, so the title is malware analysis with R2AI. So it's all around R2. Some of you might know R2, but some others might not. Radar 2 is an open source toolkit with lots of tools, and inside those you've got like the main tool, which is called R2, and it is a disassembler, a well-known disassembler. How many of you, hands raised, have already used R2 once? Yeah, quite a decent number. So for all of those, you already know what it looks like. And the others, I'd say that, one of its strengths, perhaps, is that it supports lots of architectures. I think it's even more architectures than IDA Pro, actually. And also, the other thing which might be a little bit strange at the beginning is that it's command line based, I'd say. So to navigate through the binary, you use like cryptic commands as you would use in VI. That's the code that I found there, which I find quite amusing. Radar 2 is like VI. Binary Ninja is like Emacs. And IDA Pro is like IntelliJ IDA. It turns out actually that I'm an Emacs user, but I do like Radar 2. But the comparison is pretty neat. And so in Radar 2, and R2, you have now a side project, R2AI, which is grouping all the tools to have R2 discuss with an artificial intelligence. You've got several components in there for components. one of the major components is also called R2AI. Probably had issues with namings, so the name of the project is the same as the name of the main component. In the rest of this presentation, when I just say R2AI, it's going to mean the component. And if I say R2AI project or R2AI repository, it means like the global stuff. So all the 4 components can be installed using R2's package managers. So it's R2PM, and you can install the 4. The main one, so it's going to help you discuss on one side with the AI, and on the other side, you can discuss also with R2, the disassembler, right? An important point, it's not tied to a specific model. You can virtually use any model. Well, not exactly any model, but a large number of models can be queried from R2. And to show you that, I'm going to show you a live demo with where I'm going to use it on Linux Devura. And first thing, I'm going to remove my glasses. And there we go. Okay, so maybe that's clear for you, but not yet for me. Is that okay? Okay, yeah, cool. So, actually, maybe there. We're going to launch R2PM. That's the way to launch R2AI. Okay, I'm gonna use it on my sample, and there we go. And the first thing you should notice is that you end up here in an R2AI prompt, not an R2 prompt. R2AI is really independent from R2. Okay? You can get some help with H, all the commands that you can do, and then we can ask questions. No, sorry, we've got to see which model we're talking to. So this is the one I set up, but if you want some others, you've got that. And if you even want more, like that, okay? And you just set -m and the one you want. So, for instance, do you know InsomniHack? Okay. So this is live, sorry, so we never know what it's going to answer. So, yes, I'm familiar with InsomniHack. Good. And it's annually held in Geneva. Well, not too good. Okay. But at least it's in Switzerland. And then there's a very, very neat feature. You're going to see that where you get the crocodile in R2AI, and you're going to see that one. Actually, it's in Lausanne now. I have no idea what it's going to answer. I appreciate you mentioning that it's now held in Lausanne. That's correct. Oh, that's one thing you should know, is that AIs always tell me I'm correct. I love that, but, well. Okay. The other thing, so this is not really useful for my malware, to be honest. Now I'm going to ask another question, which should be a little bit better, like decompile the main, okay? And it tells me, well, okay, if you want to decompile the main, first I need the assembly instructions for that. I'm going to send it that. And it wants more. Okay, it wants to see all the functions which are going out of the main. Let's hope it doesn't ask too many questions. So this is to see strings. Honestly, I don't know why it's asking that. I'm just asking it to tell me about the main. And then we wait. Okay. And there you go with the main, which is actually pretty good. Where I'm going to scroll up when it gets to the end. But what you will probably see, well, of course, it depends on the language model that you're selecting, okay? But what you will see is that most of the time you get some very clear output. you'll have to check everything because sometimes it hallucinates, sometimes it tells you things which are really wrong, but it's mostly clear and understandable, much more than what you would get with Ghidra's decompiler or IDEPRO. So yeah, you see here it's connecting it's connecting a socket. And those are special commands in the bot. And it's renaming itself, the process here, as kdev tmpfs. And that's what prctl is doing. And we go up to the main. And at the end, it gives you kind of a summary, okay, of what it is doing. And it tells you that we lost 22 cents. So please, at the end, 22 cents, doing the demo. So this is really the beginning of your analysis. You should not leave it here because you've got to check like what it is really doing and ask more questions. But it was really just to show you the beginning of it. Let's jump back to the slides. There we go. What you might have noticed is that I queried the model, the AI, in two different ways, sorry. The first one is that I just asked, do you know Insomniac? Just printing out the question. That's called the direct mode, and it answers what I just asked there. Very simple flow from the AI and back. Now, there was another way I queried the AI, which is called the automatic mode, which is more powerful but more complex. And I don't know if you notice, I put in front of my question here a quote and a space, which kind of says it's the cryptic way of saying I want to run this question in automatic mode. And I asked decompile the main. Then it creates context, a full context, which is going to be sent to the AI, saying first with a system prompt, basically what this is about, okay? So you are a reverse engineer and you are going to use R2 and you are meant to help to assist the end user, blah, blah, blah. Also, we are going to provide some input about the binary initial information. So those are it's going to output the response of those R2 commands and send that to the AI. So AAA is analyze all, II is binary information, and AFL is list all functions. And then the last thing, so my question, and then the last thing is we are going to tell the AI, hey, you've got a few tools that you can use to answer my question, and one of those is R2 commands, so you can send me a command, and I'll run it in R2 for you. So, to my question, decompile the main, it could have asked, it didn't this time, it was live, but it could have asked, okay, I'll decompile the main for you, but I need to find the entry point, and to find the entry point, in R2, the command is IE. Then, R2 gets that, and as IE is going to run on my host, on the end user's host, well, I get to review it and to say if I approve this command to be run or not. There's no harm there, so I say okay, it runs. R2 issues the command IE. It tells that the entry point is located at this address, and the answer is forwarded back to the AI. Then we can have like many different flows that way. The AI can ask again to send this or that command. I will approve or not. And then in the end, after a while, the AI should be able to answer my question. Hopefully there's not going to be a loop. And I get the answer to my final question. So this is the automatic mode. I mentioned the tool R2 command. But actually, there are two different tools yet. Execute binary and run Python. I think the names are self-explanatory. But of course, as all of these means that the binaries or the programs are going to run on your host, on the end user's host, it's very important that you review what is being sent and modify, accept, or not what is being sent. Okay? Artificial intelligence, most of the times, are not malicious, so they're not going usually to try to harm you, but they don't know always what is really going to be harmful or not. I explain. I was once trying to reverse a given malware, and the AI told me, well, okay, if you want this answer, I will ask you please to launch a debug session to do that. And I thought, no, I'm not launching a debug session and running the malware on my host to get infected and show you how well I get infected. Okay, so yeah, that's the typical case where you've got to pay attention and say, okay, no, don't run it, don't do it. Now, another tool, Decay. So Decay is also in the R2AI project, but it's totally independent from R2AI currently, the way it's implemented. R2AI was standalone. It had its own prompt, but Decay is going to run as a plugin of R2, meaning that you don't have like a binary Decay. You just run R2 and you will access the functionalities of Decay from within R2. It is made to help you decompile using the AI. So Decay is probably decompiler with AI assistance, okay? And when you navigate in R2 to a given function, you're going to say, okay, please decompile this one for me. And Decay is going to issue the command pdc. So maybe some of you know what that is. It's to get the pseudocode of the given function, and it will send that to the AI. And the AI, based on that, is going to generate presumed source code for it. And by the way, using pseudocode is actually a very smart idea because it consumes much less tokens than sending assembly instructions, while it contains basically the same expressivity. So it's good. And there again, I have another demo for this one. So we're going to change and use another of the malware, Goldoon. And I am going to try it with Decay. Okay, so I quit R2AI. Bye-bye, the croc. And here we go, R2, sample, Goldoon, elf. So we're on R2. I'm going to start the way most reverse engineers start in R2, AAA. Okay. Then list the functions. There's nothing that interesting. Well, not at first sight, let's say. I'm going to go to the entry point here, disassemble it. And we see that it's really like the very early entry points. It's just like calling the libc start main, which is not where I'm going to have some malicious payload. So I'm going to inspect strings. And I don't know, but like this one, the user agent saying FBI agents, this is really good. Okay, I like it. So I'm going to have a look at where this one is used. And so this is the address there. It is used twice in a function named, horrible name, whatever. This 1028. Okay? I go there and I'm going to disassemble that. And this looks far more interesting. You see that, for instance, you're getting the PID, opening the proc directory, reading, closing, doing stuff with signals, something with a socket, sleeping. Yeah, okay. So obviously, we're going to ask the AI to decompile this function for us. Decay and -h to get all the options. And then I've got to tell, the Decay which AI I'm going to query. This time, I'm going to use Mistral because I've got a free API key there. And we'll see if it works. And please decompile that one. This morning I tried and it didn't work. Yesterday I tried, it worked. Oh, good try. That's normally not the demo effect that way, but yeah. And it's pretty okay. So, well, the variable names is perhaps not as good. It could have renamed a little bit that, but we see that it's opening the procdir. In some other cases, it could have generated a nice comment for that because it seems like it's killing other process, and I would love to know exactly why. Forking, creating a socket on this address, I think this is wrong. In reality, it's taking, I think, the IP address from the arguments of the function. This is wrong, and we'll see that in a further slide. It's not exactly this name, but it's a very good start. And by the name, you see here Goldoon, which is probably why it was named Linux Goldoon, the name of the malware. So this is like, again, the first few steps you could have at decompiling a malware in there. Let's go back again to my slides. There we go. Other components in the repository. Well, I don't know if you noticed, but up to now, I have only been talking to a remote artificial intelligence. If you want, you can use a local AI. And it might be interesting, actually, especially if you have confidentiality issues. You don't want people to know exactly what you're sending, what you're asking, or things like that. Or if you have your specifically tuned model that you did pretty well and you want to use that one. In that case, you need to have a server. The server can be R2AI server, or it can be also Olama. Olama is another project, totally independent from R2 and R2AI, and it's actually the recommended way to run a local AI. And then when you want to do that, well, you basically have to tell R2AI or DK which server you are using, on which port, and which model, and it will run. I tried. It didn't work so well because I was trying it on regular hosts, my laptop and another desktop that I had. And if you want to use a local AI, you really need a powerful host for that. Okay. So it worked for simple crackmes, things like that. I would get the answer and it worked well, no problem. But on malware, I never got the answer. Okay, I got bored before. But last minute information from the maintainer of our R2AI told me that he tried this one. Okay, just that it required a pretty large amount of memory. And that it was working well. So, well, if you feel like trying this model, maybe it's a good option. Last component is R2AI plugin. Well, this is because the implementation is not very kind of coherent up to now. You've got DK, which is a plugin, and the other one, which is standalone. The ultimate idea is to have everything which is accessible from R2. Whether it is R2AI or DK, it should be like the same. So they are kind of starting to re-implement it as a plugin currently, but it's work in progress. There are some features which are working already, but not all of them. So I'd say come back in 1 month and probably you'll have something better in there. So now we're going to jump to another demonstration. So up to now, the first few demonstrations were rather to show how to begin an analysis with R2AI or with decay. Here, I'm going to use it in a slightly more advanced way. We're going to do some string deobfuscation with R2AI. It's on Root Devil, and Root Devil is a crypto miner on Linux, by the way. And this one, I have to use a video because I need some precise answers that might take a time to get again. Root Devil decrypt. So we launch R2AI on the sample. And I'm going to ask to decompile the main. As usual, it tells me, okay, I need the assembly instructions for the main, so give me that. I send that, it seems reasonable, and it's pretty okay. It is spitting out. Nice. And by the way, so all the commands here are generated by the AI, okay? So it tells me this is apparently a message sent from the malware author. The malware author, if you want to make him rich, you can send him some money on this cryptocurrency address. But I am always, cautious when I see that, because it could also very well be a hallucination of the AI, okay? So we'll check it afterwards. Here also we see that obviously it is encrypting or decrypting some blob. And here it is creating a thread to do some Monero mining. And then you get the explanation of what it believes it is doing. So I told you I'm going to check about the address, the cryptocurrency address, and it's good. It wasn't hallucination in that case. It was really in the malware itself that it's hard-coded and the message is there. Then I'm going to check about the encrypt data function. And to see, to actually address R2, I just put this in front to send the command. And I see that this function is actually used and called in 5 locations. So I'm going to disassemble one of those, a few lines around the call. And there we go. So here, let me help you out a little bit. I know it's hard to read assembly in the middle of the day. We have a call to encrypt data. And the arguments for this function are just above. This is the first argument. It's obviously an encrypted string. This one is the second argument, and it looks like, I think it's the buffer length. And the third argument, is actually the key to my encryption algorithm. So now I'm going to ask the AI to decrypt the scrim for me. The encrypt data function is called with key, so I'm explaining everything to it. This was done a little bit before by other queries. And I'm saying please do it, right? And so it tells me, okay, I need to disassemble encrypt data, which obviously it's going to need to understand the algorithm. So I say okay. And then, important there, it sends me back a script, a Python script. And it tells me that. Now I understand how the encryption works. Good. Let me write a Python script to decrypt the data, and I get that. And fortunately, I can edit that. And I recommend that you actually always edit it so that you have time to review each line and make sure that there's not something like harmful which is going around that you wouldn't want, or if you see just like an obvious error, you can fix it. In my case, I think it was not printing out the result correctly, so I fixed that. Save the buffer. Yeah, it's a bit like not very readable, but then it runs and we get the decrypted string, which is there. Okay, so this is, thanks. So this is how you can do some string deobfuscation with R2AI. Now, a little bit of results, a little bit more about comparing the analysis with what the prior researchers did on that. What really stands out is that the code the AI sends back is really clear, okay? It's clear to understand. There might be things which are missing. We'll talk about the issues a little bit afterwards, but it's really understandable, much better than what you get with Ghidra, which is closer to the assembly code, Okay. The other thing is that you don't always need to ask just things about source code. You can also ask for explanations. And for instance, I asked quite a couple of explanations about what kdef-tmp-fs was and what was the system call prctl that I did not personally know. And the answer was really also the same thing, very understandable. And also, in some cases, they renamed appropriately the flag. So here, the first flag here just shows that this is actually changing the name of the process. Clear again and useful. If we can compare to the analysis that the other humans did, also I found the AI found more, because it found out all about it's possible in this malware to put things as arguments to the program. And you can send, for instance, something like @x and then a command there. That's the format that you can run. And in the blog post of the other analysts, they hadn't mentioned that. So I don't know if they knew about it and didn't want to mention it, or that they didn't have time to see it. But at least it's something which is new that I hadn't learned from reading their blog post. And also there were special commands which can be processed in there. So run is one. There's another one around LUV. And this hadn't been detailed in the analysis. On the downsides, well, one of the most frequent one is omissions. The AI will focus on producing code which is readable, but not always complete. So it will very often forget, kind of intentionally, to explain all the details. So if this happens to you, what you have to do is to ask again and say, oh, how about you should have done this? Or I saw this in the code. Can you talk a little bit more about it? If we compare the quality, I think that as I found a little bit more and interesting stuff about the arguments in there, I think for that for this one, it's not the same results for all malware. I think this one did really actually a little bit better quality with AI assistance than without. Now, for Goldoon, that was the second sample which I showed using Decay. Same thing, very clear code with very good renaming here of variables using Claude Sonnet. That was really good. Sometimes you also have very good and wise commands. But sometimes there are things which are wrong. So here it told me that it was doing an HTTP request to /bins, /arch64, etc. In reality, if you look in the instructions, it's not that. It is going to the encrypted result of putting this string there in an encryption algorithm. It's a bit strange, okay, to do it that way, but it's the way it's done in the malware. Okay. And the AI probably thought it was too strange and decided to show it another way, but it's not what's written. So I really suggest and advise to always have like your AI assistance on one side, and side by side have also your own disassembler and check what is being done. It will also help you guide the AI correctly. So for this one, I'd say that as it found some things, I haven't detailed that, but I found some things with the AI that I hadn't seen in the blog post, but on the other side, there were some issues about some things it was saying which were correct in the blog post. I'd say that it's like roughly the same level there. For Root Devil, the last one. So here I'm showing you actually the code of the main. Well, same thing. It's really nice and really lots of details. The signals, the set file function starting various services. We have all the details of which service are being started. And there also, this was actually better than in the blog post. Because in the blog post it said that it was checking if we were root, and if we were root, then it would do something, but it wasn't clear, or I can't remember exactly what it was doing. Here, when we have the source code, well, it's not the real source code, but when we have the generated source code in front of our eyes, we see very precisely that it's actually setting different file descriptor limits if it's root or not root. So, I mean, it's interesting. I had an issue while I was reversing this one, is that the AI told me, well, I cannot advise on malware. So, you know, this one is kind of, yeah, it happens pretty often. I think that if you encounter this one, well, you've got to rephrase your question most of the time. And I advise not to use the word malware. Just use the word binary, okay? Because if you tell malware, it starts like, maybe I should not say more about this. Binary is just like enough. And for this one, well, the results are like same, also same level, approximately a level of quality. It was really very decent, very good analysis from the other researchers. But with the AI, we also got roughly also very good analysis as well. In other samples, I got some other issues, like extrapolations. So this one, as you can see, you have a line with a printf, which is printing out, just displaying actually a MAC address. And the AI said, okay, contains MAC address manipulation code. Like, this is really like just a marketing brochure, okay? They're exaggerating. It's not manipulating anything at all. It's just printing it, okay? So this is, again, something that you have to check with the assembly code or with another decompiler, or you can just ask again the question and see if it's really repeating itself. Worse are hallucinations. Hallucination is where the AI is completely inventing something. So here I was reversing a botnet, and it's just created 2 new botnet commands for me because it felt I would be happy with those, I think. Okay. So file download and file upload were totally created. In reality, in this botnet, there was a file transfer command, which was actually doing in one go both sides. So you could have like go to the bot or go to the bot master with a single command. But there were no way those file download and file upload commands. This is because, well, AIs are sometimes a little bit too much trying to please you and to give you things that look like they could really occur, but they did not exist. So this has to be checked again, asking again the questions or checking with the assembly code. Another example was with the Linux Prometheus botnet. So this one is really recent. It was like less actually than 1 month ago. 1 month ago. And I was investigating this one, and I told the AI, well, that I was particularly interested in encryption algorithms. Told it, okay, can you spot any encryption algorithm in this sample? It told me, yes. I found RC4. I was impressed for at least a few minutes. And then I had a look, and I thought, wow, this is RC4. Then I investigated a little bit more. It was a hash function. SHA-256. Okay. So here it really wasted my time, to be honest, because I really thought, well, is it like modified RC4? And I had really to check really what it was doing. And then, well, it was obvious it wasn't RC4 at all. And worse than that is that there was RC4 elsewhere, but the AI hadn't spotted it. Okay. So the solution is, well, ask again. Don't ask with the same context, okay? If you always use the same context, there are commands in R2AI where you can reset the context so that it starts out blank. And if you get the same hallucination again, well, you're either really unlucky or maybe it's not a hallucination, okay? So just try again, and see if it really makes sense or not. Costs. So far, this is my experience with decay and the direct mode. You can decompile all day long for $1 or $2 without any problem. Okay. With the automatic mode, it can go a little bit higher, up to like $10 or something like that, and you might want to check that it's not going beyond control. There are ways to do that in R2AI. You've got some limits that you can say. So basically, you are paying by the number of tokens. So you can try and reduce the length of your token, your tokens, which is always a good idea. You can also limit, the how many interactions you're gonna have in both ways with the AI. By default, it sets to 100, which is enormous. Never go up to 100 interactions. If it hasn't answered by, I'd say, 15 interactions, it's dead. I mean, start again, reset the context, and ask again another way, or just do it by your own, okay? How much time did it save? So this is a little bit more difficult because it's always difficult to know how much time I would really have spent on each of these samples with and without AI. But roughly, I estimated that I save for each of those between half a day and 3 days of work. So it's honestly pretty good, at least for my employer, because 3 days for $10, well, I'm paid a little bit more, fortunately. It's a very good ratio, okay? So what should you remember about this is, well, the first thing, I'd say the first conclusion on my side is that I was really very happy. It's the first time I have, at last, a new tool for decompiling malware, which is a significant advance. We've had a few add-ons on decompilers to work to process better, I don't know, Android, Flutter, many things, Go and everything. But it's like a small addition. Here, I get really some decompiled code, which is really so much better than I ever had, that it's really saving lots of time and more understandable. So this I really appreciate. I do understand, of course, I'm not naive, that AI is being used by malware authors, but at least I am using it as well. So, it's like more of a balance there. The other thing is that you cannot expect the AI to give you a good answer in just a single shot. Okay, it's not going to be 10 seconds. The analysis in all of these, the 3 that I showed you, it was like maybe half a day or maybe a little bit more of an analysis. Consider it's more like you're discussing with a smart colleague of yours, but with less experience. So you have to talk with a colleague and to guide him to something which is going to go towards the way you want. Okay, this is exactly how it's going to work with the AI. In terms of really malware analysis stuff, so with string obfuscation, as we saw, it works with basic string obfuscation and medium complexity obfuscation that we can have. If it's really very hardened obfuscation, I wouldn't be sure it would manage to do it yet, but it's probably very much improving. When it comes to packers, so many malware are packed, unfortunately, and the AI so far hasn't been able, in the cases I tried, to unpack the malware. So you have first to unpack your malware and send it to the AI, which is actually exactly the same when you're using the standard decompilers, either Pro and Ghidra and Binary Ninja or whatever. You never, you probably won't be disassembling your packed binary. You will first unpack it and then put that in the disassembler to understand what it's doing. And last but not least, do not trust what the AI says. This is really important because the AI is a very, very good storyteller, okay? And it will convince you, and you've got to stay still alert, not to be able to criticize and to check what it is saying all the time. This is kind of difficult. But really be warned, if you're not checking, sooner or later, you'll make a fool of yourselves, okay? Unfortunately. The other thing, final comment I would make on that is that given the fact that you need a little bit of experience to guide the AI, and also to be able to criticize it, to say, okay, this really doesn't seem correct, okay, it's not going to be that adequate to use if you're a beginner. I think, or that's the way I feel, that if you're a beginner in malware analysis, you should first learn to do it yourself to make your own experience. And once you know really well how to do it, then you will probably benefit much more from AI, because you will be able to guide the AI correctly towards the solution. And that's about all. I would first, however, like to thank, Sergio Alvarez and Daniel Nakov, who are both R2AI maintainers and contributors for the nice work they've been doing, and of course also my husband there for his very nice AI ideas and discussions that we had around that. And I'm ready to take your questions. Yeah. I can do also, if some of you really want to see it in action on a given sample. After that, well, you can come and I can try and do a demo with the sample you have.
Thanks for the talk. Have you compared various models, and is there one that gives better output than others, or are they mostly equivalent?
Yeah, I have. So I tried ChatGPT, DeepSeek, Claude Sonnet 3.5 and 3.7, which is the most recent one, and a couple of others which were local. So on the ones which were local, to be honest, my tests are not relevant. I've got to try with a better configuration. And on the others, I always got the best answers with Claude Sonnet. It's the way it is currently. Maybe it might evolve, but in terms of getting code readability and things like that, it always was really much better than the others. Yep, in the middle.
Thanks, great speech. As it's always a cats and mice game between malware programmers and malware analysis, are you aware or do you have any concerns about countermeasures that can be taken by malware programmers, like, for instance, inserting dead codes in malware to lead to AI hallucinations?
Yeah, it's a good question. It's a very good question. I haven't seen that yet, okay? I haven't seen any malware author which would intentionally put something in the code that would lead to hallucination, because I'm not sure that they are able to reproduce it yet, okay? To do it that way. But you are right. Probably it will happen one day, but as there are many models, it's going to be difficult again for them to be able to have something which is going to hallucinate on Claude and is also going to hallucinate on ChatGPT, on DeepSeek, on Grok, and all the others. So probably on this end, yeah, it looks like a little bit more equal, because I'd say that what I feel as a malware analyst is that it's always very hard for us to counter the malware authors. At least here, I feel like we're at the same level.
Thank you.
And by the way, the crocodile there, well, it's a crocodile. It's not a frog, okay? Okay. Thank you very much.